Hi, Abby. So we're gonna walk through this problem together. So I have to recall that the Earth's radius is 4,000 miles. So I'm drawing the Earth right here, and the radius right here is 4,000 miles. Okay. Now I want you to pretend that you are like a colossal giant, right? And you're standing right there at that spot on the Earth. And if you were looking out at the horizon, you could see probably as far as that spot right there, right? That's about how far it would be like tangent for you to be able to see. You can't see down here, right? Because to see down here, you'd have to be like looking through the Earth. You can't do that. And you can see farther than, say, right to here, because, you can kind of stretch your vision out to there and stretch your vision out to there. So you can stretch your vision as far as it takes to be tangent with that circle. Now, to look at it just slightly, so let's put back in the tangent, so that, like, you can see, like, really just like to right that spot right there. If you were lying down flat, so your head is like right on the ground, right? Here's your body, right? Your head is flat on the ground. Well, you can't see anywhere. All you can see is like the exact spot that you're at, because the Earth is curved, and if you're looking straight out, you couldn't see anything, right? So we're trying to find, I believe, make sure you answer how far is the horizon away when you stand 6 feet above sea level. So we're trying to say, and you have to get this idea that this is a drawing that is not to scale, right? But we're trying to say that this distance right here, your height, is 6 feet, or you are standing 6 feet. We're really not considering the additional height of how tall you are. You're 6 feet, and this distance here is 4,000 miles. And I need to find the length of your line of sight. So again, not to scale, but I think you'll get the picture here. You're looking out, and you can see as far as this spot right here. So what I want you to visualize is a triangle. One side of the triangle is from this spot, which is as far as you can possibly see, to the center of the Earth. Now, this is your line of sight. Again, I'll draw it in a different color since you're not watching me do this. So let's draw it in black here. This is your line of sight. And since it is tangent to the circle at that point, we know that that is a 90-degree angle. And we also know then that that's a 90-degree angle, that this is the hypotenuse of the 90-degree of the triangle, and that is 4,000 miles plus 6 feet, because I have the radius of the Earth plus the 6 feet that you are standing above the surface of the Earth. So I think the easiest thing to do here would be to change everything into feet. So I take 4,000 miles, 4,000 times 5,280. So, well, that's a big number, huh? Yeah, but I'm going to do it anyways. Okay, so I have 21,120,000 feet is 4,000 miles, so that's this distance right there. And I have 4,000, and I have clear, sorry. And I have 21,120,006 feet is the hypotenuse. So if I take this length of the triangle and I square it, and I add b squared, which is our line of sight, which I don't know the distance, that is going to equal 21,120,006 squared, right? A squared plus b squared equals c squared. Let's see if we can't do it. So I'm going to square that. Oh boy, that's a big number. That's okay, we're going to do it anyways. We can do it. So 4,000, this number here squared is equal to 4.460544 times 10 to the 14th plus b squared is equal to, now I got to do 21,120,006 squared, and I get 4.460546534 times 10 to the 14th. I think so far so good. So if I subtract this from both sides, I'm going to have 4.460546534 10 to the 14th minus 4.46054 0.000 times 10 to the 14th.
Please excuse the interruption, but wait.
So the 10 to the 14th is a common term. It's like I said, 4x minus 3x. 10 to the 14th is just like my x. So I have here, these all cancel out. I have 2, 5, 3, 4, 10, or 0.000000. I gotta make sure I got the right O's. 1, 2, 3, 4, 5 O's. 1, 2, 3, 5 O's. 0.2534 times 10 to the 14th. So I have, between those two, I have, I'm going to now take it to the 14th. So I'm going to move this over 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 0, 0, 0, 0, 0. So I have 2, 5, 3, 4, 0, 0, 0, 0, 0. So I have this. Something's wrong. Maybe it's not wrong. Let's keep working with it for just a minute. This is the difference. So this is I subtracted the a squared from the hypotenuse squared. So this number here is equal to b squared. I'm doing it on the calculator right now. And 25, 253, 4. So I'm getting a little bit of I'm getting a different number. But I must have just done something with my decimals. So I hope I'm not confusing you too badly here. But let's just look at this right here. This, we're going to get this, Abby. This number right here was my a squared. that was this number here squared. And again, looking at the calculator, this number right here, you can see my arrow going around, was my hypotenuse squared. So using the calculator here, I just took this number right here, and I subtracted this number right here, and I got this right here, 253,440,040. So I got something like this number here, but I just had the wrong number of decimals, so excuse me for that, but I think you can see what I'm doing. And since that is equal to b squared, all I need to do is take the square root of that, so I go caret 0.5, and so that tells me that the length of my line of sight right here, my B, is 15,919.80 feet. Of course, I could have read the problem all the way through the first time and say he wants it in miles. I can just divide that by 5,280, and I get a little bit over 3 miles would be the length of my line of sight. I could have done it the other way, where instead of using all these big giant feet, I could have changed this side right here into, so 6 feet, I'm going to go to the calculator again, 6 divided by 5,280 is that number right there, and I could have just added that to the 4,000 miles. Might have been a little bit easier. Might have come out a little bit easier that way. But then I would still have the same process of 4,000.001136. That's my hypotenuse, so I would square that. I would square the 4,000, and I would still get what my B was. So I hope this helps you visualize it. If it doesn't, send me an email back, and I'll try working on it some more.